Hello viewers, this is the second lecture on resolution of vectors. And I'm very sure for those of you that have seen my video, the first lecture on resolution of vectors, you have learned one or two things and you have familiarized yourself with the four cases that we discussed in the first lecture. Now, we want to discuss more on resolution of vectors. That is, we want to talk about another different case entirely from all those four cases that has been discussed. If you have not seen the first lecture, I would like you to check below for the link to watch the first lecture. Now, the case whereby we have two or more vectors acting in different directions with respect to fixed vertical and horizontal axes, y and x respectively. If we have vectors acting in this form, just as illustrated in this figure, how do we resolve them? How do we find their resultant vector? We have six vectors here, vectors v1, v2, v3, v4, v5, and v6. Each vectors are acting in one direction or the other with respect to the x-axis and the y-axis. v1 is at an angle θ1 to the x-axis. v2 is at an angle θ2 to the x-axis as well. The same thing with v4, with an angle θ4 to the y-axis, while v5 and v6 are directly on the x-axis and the y-axis respectively. Now, how do we resolve vectors in this case? I would like us to do it together. Starting from vector v1, one of the things we consider is the sign that each vector is going to take. Vector v1 is acting on the right hand side of the x-axis. This implies that for the x-axis, vector v1 is going to have a positive value with respect to the x-axis. Also, this vector v1 is acting at the top. So considering the y-axis, it implies that vector v1 is also going to have a positive value with respect to the y-axis. Now, let us look at vector v2 as well. Vector v2 is also on the right hand side. This implies that vector v2 will have a positive value as well with respect to the x-axis. But v2 is acting below, which implies that with respect to the y-axis, it is going to have a negative value. Before I proceed further, let us take a look at vector v4. v4 is acting at the left hand side, which implies that with respect to the x-axis, vector v4 is going to have a negative value, while with respect to the y-axis, because vector v4 is acting at the top, it is going to have a positive value. Now, let us illustrate the action of each vectors with this table. Starting from vector v1, I want to resolve vector v1 with respect to the x-axis. Don't forget I said already that vector v1 is going to have a positive value. So permit me to write the plus sign. Now, considering the x-axis, the next thing I need to consider is the magnitude of vector v1, which I will write this way. Now, the last thing that I need to consider is this direction. θ1 is the angle between x-axis and vector v1. Because the angle is directly found between the axis that I'm dealing with, which is the x-axis, and the vector that I want to resolve, this will make me use cosine of the angle θ1. If otherwise, that is, as I'm dealing with x-axis presently, If angle theta 1 is found with the y-axis and yet I'm dealing with the x-axis, then I'll make use of sine of this angle. Let's proceed to vector v2, still talking about the x-axis. For vector v2 as well, like I said earlier, vector v2 is on the right hand side. Definitely, it is going to have a positive value. The next thing that follows as well is the magnitude of vector v2. Now, the angle theta 2 is in between the x-axis and vector v2. That implies again that I'm still going to make use of cosine of this angle. That is cos theta 2. Proceeding further, still on x-axis, I want to resolve vector v3. Vector v3 is on the left hand side, which implies that it is going to have a negative value. That is, instead of using a plus sign, like in the case of vector v1 and vector v2, I will make use of a minus sign. Then, just like the other cases, it is the magnitude of the vector that will follow. Then in the case of the angle theta 3 is the angle that v3 is making with one of the axes y or x. But in this case, vector v3 is making the angle theta 3 with the y-axis, whereas I'm dealing with the x-axis presently. This implies that I will not make use of cosine of the angle theta 3. Instead, I will make use of sine of angle theta 3, simply because the angle is not directly between vector v3 and the x-axis. Instead, it is with the other axis, which I'm not dealing with presently. So I'll make use of sine of theta 3. Another case is the case of vector v4. Now, in this case as well, vector v4 is at the left hand side. Obviously, from what we've done earlier, it will also have a negative value followed by its magnitude. Then angle theta 4 is in between v4 and the y-axis, and yet I'm dealing with the x-axis, which implies that I will not make use of cosine of the angle theta 4. Instead, I'm going to use sine of the angle theta 4. Now, for the case of vector v5, this is a special case in that vector v5 is acting directly on the x-axis. That is, mere looking at it, it is not acting at a particular angle to the x-axis, even though it is acting at an angle 0 to the x-axis, then at angle 90 degree to the y-axis. But that's not very, very important to be considered. Since v5 is on the left hand side, then we can say that the value of v5 while resolving will take a negative value for the x-axis because it is on the left hand side. So we have minus. Then what follows, just like the other case, is the magnitude of vector v5. Now, because v5 is directly on the x-axis and I'm resolving with respect to the x-axis presently, that implies that the angle between the x-axis and vector v5 is 0 degrees, which implies that I'm going to make use of cos 0 degrees. Now, the case of vector v6, it is acting directly on the y-axis. Obviously, you cannot even determine what side it will take with respect to the x-axis because it is neither on the left nor on the right of the x-axis. We can say V6 is neutral as far as x-axis is concerned. So the sign is indeterminate first. Now, if we represent the magnitude, which is magnitude of V6, like I said, the angle that V6 is making with the x-axis, because V6 itself is directly on the y-axis, and y-axis is perpendicular to the x-axis. That is, y-axis is at angle 90 degrees to the x-axis. That implies that the angle that V6 is making with the x-axis is 90 degrees. Therefore, I'm going to make use of cos 90 degrees. Now that we are done with the 6 vectors for the x-axis, now let us resolve the 6 vectors with respect to the y-axis as well. Starting from vector v1, considering the fact that v1 is at the top, which implies that for the y-axis, the value of v1 is going to be positive. Then what followed? Followed by the magnitude. Then the next thing is that angle theta 1 is formed with the x-axis, and yet we are dealing with the y-axis now, which implies that we are not going to make use of cosine of the angle, simply because the angle is not between the vector that we are dealing with and the axis that we are resolving to, which implies that the sine of the angle theta 1 is going to be used. That is sine theta 1. Now, moving further to vector v2. V2 is below, which implies that we are not going to make use of positive value of v2. We are going to make use of the negative value of v2. Now, let us proceed to the angle. Vector v2 is making angle theta 2 with the x-axis, but as you know, we are dealing with the y-axis presently. Definitely, sine of the angle is what we will use. Proceeding to vector v3. V3 is also below, which implies that we are going to have a negative value of v3 with respect to the y-axis. Now, the angle theta 3 is in between vector v3 and the x-axis and the y-axis, and we are dealing with y-axis presently. That implies that we are going to make use of cosine of theta 3, simply because the angle is directly in between the vector that I'm resolving and the axis that I'm resolving to presently. So I will make use of cosine of angle theta 3. The next one on our list is vector v4. Vector v4 is at the top, which implies that it is going to have a positive value with respect to the y-axis. That is, we have plus followed by the magnitude of vector v4. And considering the direction, that is the angle between v4 and the y-axis, which this implies that I'm going to make use of cosine of the angle theta 4. Now, straight to v5. v5 is directly on the x-axis, and I'm resolving with respect to the y-axis. Now, v5 is perpendicular to the y-axis. That implies that the angle between v5 and the y-axis is 90 degrees, which implies that, again, the sign is going to be neutral. Reason being that v5 is neither at the top nor below. So we cannot determine what angle, what sign it is going to have. But the angle between v5 and the y-axis is 90 degrees. Therefore, we can only say we have the magnitude of V5, then cos 90 degrees. Now, to the last vector, which is vector V6. V6 is directly on the y-axis. That implies that V6 is acting at angle 0 degrees to the y-axis. And as well, it is at the top, which implies that it is going to have a positive value with respect to the y-axis. Then we can write the plus sign followed by the magnitude of the vector V6. Then the angle between V6 and the y-axis is 0 degrees. So we have cos 0 degrees. Okay, let's take an example. We have different forces, 5 Newton, 20 Newton, 7 Newton, and so on, acting in this figure at different direction with respect to the x-axis and the y-axis respectively. Now the question says we should find the magnitude and direction of the resultant force in the figure above. Now, this is the list of all the forces acting in this figure. We have the force 5 Newton, well represented here, 20 Newton, 3 Newton, 15 Newton, 10 Newton, and 7 Newton. Now, like we have illustrated before, we said that for 5 Newton is at the right hand side. Definitely, when we want to consider it with respect to the x-axis, it is going to have a positive value. And the magnitude of 5 is still 5. Then, if you observe here, between 5 Newton and the x-axis, which we are dealing with presently, there's no angle in between them. Instead, the angle is made with the y-axis, which implies that we are going to make use of sine of this angle. So we'll make use of sine 45 degrees. Now, let's move down to 20 Newton. If you look at 20 Newton is acting directly on x-axis. In fact, it is acting directly on the positive x-axis. Definitely, it's going to have a positive sign. That is, we'll have plus. Then, the magnitude of 20 Newton is 20. And as well, the angle between 20 Newton and x-axis is 0 degrees. So definitely, we have cos 0 degree. Moving to force 3 Newton. For the force 3 Newton, it is also on the right hand side, which implies that with respect to the x-axis, it's going to have a positive value. Now, the next thing is the magnitude of the force, which is 3. Now, the angle between 3 Newton and the x-axis is 30 degrees. And because the angle is directly between the 3 Newton and the x-axis, which we are dealing with presently, this implies that we are going to make use of cosine of 30 degrees. The next force is the force 15 Newton. 15 Newton is directly on the y-axis, but with respect to the x-axis, it is neither at the left side nor at the right hand side, which implies that in terms of sign, we don't know which one to put. But the magnitude of 15 Newton is still 15. Now, the angle between 15 Newton and the x-axis is 90 degrees. That is, 15 Newton, since it is directly on the y-axis, then it is perpendicular to the x-axis. So we have cos 90 degrees. The next force is the force 10 Newton. 10 Newton is on the left hand side with respect to the x-axis, which implies that it will have a negative value. Then the magnitude is 10, and the angle 70 degrees is made with the y-axis and not the x-axis. This implies that we are going to make use of sine of 70 degrees. The last force which we are going to consider for the x-axis is the force 7 Newton. 7 Newton is also at the left hand side for the x-axis, which implies it is going to have a negative value as well, and the magnitude is 7. The angle 60 degrees is made directly with the x-axis, which is the axis we are dealing with presently. So we have cosine of the angle. Now, let us treat the case of the y-axis, starting from 5 Newton as well. 5 Newton is at the top. Definitely, it is going to have a positive value with respect to the y-axis. So we have plus sine, followed by 5. Then, the angle 45 degrees is directly between 5 Newton and y-axis. Then we have cosine of 45 degrees. The next one is the force 20 Newton. The force 20 Newton is directly on the x-axis, which implies that with respect to the y-axis, the side that 20 Newton is going to take is indeterminate. Then we cannot know the side that we'll put here. Now, the angle between 20 Newton and the y-axis, because x-axis and y-axis are perpendicular to each other, this implies that the angle between the 20 Newton and the y-axis is 90 degrees. So therefore, we put the magnitude, which is 20 Newton, then we use cos 90 degrees. Proceeding to the next force, which is force 3 Newton. Force 3 Newton is below, and we are considering the y-axis. This implies that this is going to take a negative value with respect to the y-axis, and followed by the magnitude, which is 3, and the angle 30 degrees is made with the x-axis, whereas we are dealing with the y-axis. This implies that sine of the angle 30 degrees is going to be used. The next force, which is the force 15 Newton. 15 Newton is acting directly on the y-axis, and it is found below, which means it is going to have a negative value, and again followed by its magnitude. Then the angle between 15 Newton and the y-axis is 0 degrees. So we have cos 0 degrees. The next force, which is force 10 Newton. 10 Newton is also found below. This implies that 10 Newton is going to have a negative sign for the y-axis as well, just like it has in the case of x-axis. Now, followed by the magnitude, which is 10. Then, the angle 70 degrees is made with the y-axis, which implies that I'm going to use cosine of 70 degrees. So, I will make use of cos 70 degrees. And to the last force, which is force 7 Newton. 7 Newton is at the top with respect to the y-axis. That implies that it is going to take a positive value. Also, the angle 60 degrees is made with the x-axis, which implies that I'm going to make use of sine of 60 degrees because I'm dealing with the y-axis presently. So I will have the magnitude, which is 7, and I will have sine 60 degrees. Now, the next thing to do now is to grab our calculator and get the values of each of these one by one, because these are the values that we will use to compute our resultant force. Okay, now that we have gotten values for all of these, the next thing for us to do is to find the summation of all the values that we've gotten here. And if you compute this very well, you're going to get 13.23 Newton. That is the total force that is acting on the x-axis. This is the resultant of all the forces with respect to the x-axis. As well, for the y-axis, this is the total forces that is acting on the y-axis. The negative value here is showing that the effect of this force is felt on the left hand side of the y-axis. And for this x part, because it is positive, it's showing that the resultant here is felt on the right part of the x-axis. Now, if we remember, as we discussed in case 3, the case of two vectors acting perpendicular to each other. And we've also said from the beginning of this lecture that x and y axis are perpendicular to each other, which implies that this resultant vector that we have gotten for the x axis is going to be perpendicular to the resultant vector that we have gotten for the y axis. Then, using the formula for finding the resultant vector, as it has been said in case 3, the resultant force now will be equal to the square root of 13.23 squared plus minus 10.33 squared. And if we press this on our calculator, the square of 13.23 squared is 175.03 plus the square of minus 10.33 square is 106.71, and this will give us, if we add 175.03 with 106.71, we have 281.74. Then we get the square root of this, the square root of 281.74 is equal to 16.79 Newton, which implies that the magnitude of our resultant force is 16.79 Newton. Now, let us find the direction of our resultant force. Still using the method that we used in case 3, we make use of arctan of minus 10.33 over 13.23, which will give us theta, the direction of the resultant vector. And if we press this on our calculator, theta will be arctan minus 10.33 divided by 13.23 will give minus 0.7808, and therefore the arctan of minus 0.7808 is equal to minus 37.98 degrees. Now, we have the direction of the resultant force to be minus 37.98 degrees. What is this telling us? This is telling us that, like we said in case 3, we said the angle that we are getting here is if we take our frame of reference from the x-axis, because we have measured the angle in the clockwise manner. Thank you for watching. This is the end of our lecture on resolution of vectors. Kindly subscribe to watch more of our tutorial videos. Thank you.